Yeah. So, good morning, all of you. Is it inaudible? Audio videos, everything is clear. So, please. So, let us understand first what is in exactly our agenda for today. What is in exactly our agenda for today? Today, we are going to be discussing about what is DevOps. So, total, the course name is what is DevOps with what? Multi cloud. DevOps with what? Multi cloud. In this, AWS administration we're going to be learning. Azure administration we are going to be learning. DevOps with what? Multi-cloud. With these two courses, we are going to be learning. These three courses, we are going to be learning under this course. Okay, before starts, let us understand the course overview. Let us understand the course overview. So totally, we are going to be discussing three courses. One is DevOps with multi-cloud, Azure administration, AWS administration. AWS administration. Total duration of this course is 5 months. Total duration of this course is 5 months of duration. Which are all the prerequisitions? Linux basics, shell script, no programming, Java.NET is not required. You require a laptop with this configuration, for daily practice. And who can join in this course? Freshers can join in this course. Experienced students can join in this course. Any non-IT student also can join in this course. Any graduate can also join in this course. Which are all the benefits? Daily class recording videos after the payment. Via Google Drive, you can join from here. Resume preparation, interview question and answers, 4 live real-time projects. I'm going to be providing with the course materials. Course starts with very basic level, finish with what? Advanced level. Each and every class is a practical implemented in front of you. And after completion of course, you will receive one course completed certificate from our institute. Daily 1 hour class. The classes are from Monday to Saturday. You're going to be paying. So you're going to be whatever amount, whatever the transaction, please do this number 9297 777. You can call, WhatsApp and talk to them for the communication. Okay. This is our course content. Before starts, let us introduce myself. Okay, my name is Maha. I have totally 15 years of IT experience. My career starts with Java developer. Then I turn as a DevOps engineer. From Last 5 years onwards, I'm working as a senior DevOps engineer. It is include AWS and DevOps. It is include AWS and Azure also. So this is exactly my profile. And before starting, I have 3 questions. Which are all those? Yes, please. What is an application? Second question, what is the server? Third question, what is an SDLC? What is an application? The working software. The working software which is written any programming language. The working software which is written any programming language, we call as an application. That application we're gonna be placed on server side. Once if it is placed on server side, once if it is placed on server side, and we can access our internet as a website like Flipkart or Amazon, book my show. Book my show. But what about SDLC? What about SDLC? SDLC is a software development lifecycle. SDLC is a software development lifecycle. In SDLC, we have several stages and several phases. Several stages and several phases, guys, please. Like analysis, design, implementation, testing, deploy, and maintenance. By following these all the stages and phases, we have analysis, design, implementation, testing, deploy, and maintenance. By following these all the stages and phases, we can able to produce an application and we can able to do business in internet like Flipkart or Amazon, book my show. But for implementing this Flipkart, Amazon kind of thing, then so we can able to do business. So for example, if you want to build Flipkart kind of application, book my show kind of application, Redbus kind of application, what we need to do, please? First step is what? Analysis. Gathering information from the client. Analysis means what? Gathering information from the client. How exactly the login page, registration page, each and everything will be gathered. Based on gathering information, our architects will be designed. Design is nothing but a plan. Design is nothing but a plan. According to the planning, our developers will implement the lines of code. Once if it is an implement the lines of code, whether it is working or not functionally, our testers will be verified. Once if it is successfully done verification, and we're going to be deploy our applications on hundreds of servers, placing our applications on hundreds of servers. Once if it is placed on hundreds of servers, we can access our internet as a website like Flipkart or Amazon, book my show. Once if it is done, and we're going to be maintenance, whether it is working or properly or not. This entire process which you are calling as what? Software development lifecycle. In this software development lifecycle, our roles and responsibilities start from dev environment, ends with what? Operations. Ends with what? Operations. ends with what? Operation. That means we are part of coding, building, testing, release, deploy, operation, and monitoring. To be frankly, we are not writing any coding. We are not writing any test cases. Just we are going to be implementing an automated DevOps transparent pipeline. An automated DevOps transparent pipeline. In this DevOps transparent pipeline, in this DevOps transparent pipeline, so we need to follow. DevOps is a technology like Java, .NET, Python. No, DevOps is not a technology. DevOps is a process. DevOps is an automated process. While we implementing an automated DevOps process, we are following some rules and regulations. Which are all those guys, please? Let me explain with an example. For example, we are going to be writing these lines of code. We're going to be making working software. We're going to be delivering it to the production environment within a shortest time, with high quality, with low cost is nothing but what exactly our DevOps transparent pipeline. But as a DevOps engineer, we are going to be replacing with what? As a DevOps engineer. As a DevOps engineer, what exactly we are going to be replacing with what? Complex pipeline with what? Transparent pipeline. So our SDLC process is a complex pipeline. Sir, why we are calling our SDLC as a complex pipeline? Because of it is a manual process. From analysis to design, design to implementation, implementation testing, testing to deploy, deploy to maintenance, it is a manual process. Due to this manual process, while delivering our application, if we got an issue, any problem in middle of the process, for identification, it will take long time. For resolving issues, it will take long. If it is take long time, definitely cost will be increased, the quality will be decreased. So that is the reason we are going to be replacing with what? Replacing with what? Our DevOps transparent pipeline. While replacing DevOps transparent pipeline, so while implementing this an automated process, even though if you got an issue, easily we can able to rectify, easily we can able to resolve. That means the cost is reduced, the quality will be increased, and customer is satisfying. Sorry. Customer is satisfying. That is the reason we are going to be replacing with what? Complex pipeline with what? Transparent pipeline. But actual DevOps transparent pipeline is look like this. In this DevOps transparent pipeline, we have a plan, coding, integration, testing, release, deploy, operations. In this DevOps transparent pipeline, our roles and responsibilities start from dev environment, ends with operations. That means we are part of coding, integration, testing, release, deploy, operation. To be frankly, we are not doing any planning. We are not writing any coding. We are not writing any test cases. Just we are going to be implementing an automated DevOps transparent pipeline from dev environment to operations. While implementing this DevOps transparent pipeline, we have to follow some rules and regulations. Which are all those guys, please? Whatever the lines of code is written by developer that we are gonna be delivering into the production environment within a shortest time, with high quality, with low cost, is nothing but what exactly our DevOps transparent pipeline. Clear? But how we can able to implement this DevOps transparent pipeline by helping our tool stack. Which are all the tool stack, guys, please? Git, GitHub, GitLab, Maven, Jenkins, JFrog, SonarQube, Ansible, AWS, Azure, Docker, Kubernetes, Elastic Logstack, Kibana, and Grafana, and Terraform. So these are all the tools we are gonna be using for implementing our DevOps transparent pipeline. Sir, how exactly we are gonna be using these are all the tools in our DevOps process? Let us understand one by one. Let us understand one by one. Let us understand one by one, guys, please. So let us start with what Git. Git is a version. Git is a version control. So whatever the lines of code is usually, are we part of planning? No, we are not part of planning. Are we part of dev environment? Yes, but the writing is responsible by the developer, not by you. The writing is responsible by the developer, not by you. The writing is responsible by the developer, not by you. Whatever the lines of code is written by developer, those lines of code we're gonna be maintenance. So writing by developer and maintenance by DevOps engineer. Writing by developer, maintenance by DevOps engineer. How exactly we can maintain? By helping of Git. Git is a version control. All developer lines of code we're gonna be maintained. We're gonna be maintained as a version wide in a source control by helping of Git. And once if it is maintained, those lines of code we need to execute by helping of Maven. Maven is always built. Maven is a build tool. Maven is a build tool. It is always produce an active factory. It helps to manage dependencies. By executing Maven, it can be always generate an active factory. So once if it is generate, once if it is maintained, by helping of Jenkins, we are gonna be continuously integrate. Whatever the lines of code is written by developer, all developer lines of code continuously integrating. Once if it is an integrate, we're gonna be making working software by executing test cases. Once if it is an execute test cases, and we're gonna be delivering into the release. So continuous integration, making working software, continuous delivery. This entire process we are calling as what? CI/CD. This entire CI/CD we can automate Jenkins. Once if it is continuous integration, continuous delivery, where exactly we're going to be delivering our application into the release. The release is nothing but what exactly the JFrog. Yeah, repeat again. By helping of Git, Maven, Jenkins, JFrog, SonarQube, we are going to be implementing our CI/CD process, continuous integration, making working software, continuous delivery. So once if it is successfully delivered, once if it is successfully delivered, and we're going to be deploying our applications on hundreds of servers, placing our applications on hundreds of servers, placing our applications on hundreds of servers. Once if it is placed on, once if it is successfully deploy our application, we can access our internet as a website. But how exactly these hundreds of servers we can able to manage? By helping of configuration management. By helping of configuration management. By helping of configuration management, we're going to be replacing with what? Manual configuration process with what? An automated process. An automated process. Once if it is successfully, once if it is successfully replacing a manual process with an automated process on a hundreds of servers, at a time, we calling as what? Configuration management. This configuration management we can able to do by Ansible. Ansible is a configuration management tool. But this servers, how many ways we can able to get it? We can able to get it either by physical environment or virtual environment or from cloud. Or from cloud. Either by AWS or Azure. So let me repeat again. By using AWS, Azure, Google, we can able to get hundreds of servers. These hundreds of servers we can automate by helping of Ansible. So not only placing our applications, our websites on AWS, Azure, Google servers, we can able to place our applications on Docker containers also. What is an exactly Docker container? Docker container is an isolated area. Docker container is an isolated area which can place our websites very easily with low cost, with high quality, with low cost, with high quality. So simply let me explain this. For example, let's say if you are using real-time containers, please. Real-time containers. How exactly we can able to use? How exactly we can able to use this? So for transporting, import, export, whatever maybe you are not telling. Import, export. Whatever maybe we can do it or not telling. Yes. Clear. Import, export, whatever maybe. But like goods, services, whatever maybe. So with the high quality, with low cost, the same way, our Docker containers also can can do the same, but here is what exactly, like Java application, .NET application, Python, Flipkart, or Java kind of application. Very easily we can able to manage. Very easily we can able to deploy, and with low cost with high quality. How exactly these containers can manage or control by ship the same way? All how exactly this containers can manage by the ship, a single ship can manage all the containers the same way. All our Docker containers can manage by all our Docker containers managed by Kubernetes. Kubernetes is a orchestration tool. Kubernetes is an orchestration tool. Kubernetes is a orchestration tool. By helping of Kubernetes, by helping of Kubernetes, we can able to automate our infrastructure. Our infrastructure. Our infrastructure, and moreover we can able to automate our Docker container. All our Docker containers we can able to manage, we can able to control by using Kubernetes. And we're gonna be learning Elk. Elk is a elastic log stack schema. By helping of Elk, we can able to monitor our application, whether it is slow or speed. Each and everything will be monitored, and it will give statistics and reports also. By helping of Terraform, we're going to be learning Grafana. Grafana is a monitoring tool, and we're going to be using Terraform. Terraform is a cross cloud platform. By helping of Terraform, we can create infrastructure in any cloud, either AWS or Azure or a Google. Terraform is a cross cloud platform. Terraform is a cross cloud platform. By helping of Terraform, we can create infrastructure in any cloud. Got it very clearly? I hope you people are understands very clearly. By helping of these are all the tools: Git, Maven, Jenkins, JFrog, SonarQube, Ansible, AWS, Azure, Docker, Kubernetes, Elk, Grafana, Terraform, we can be able to implement our DevOps transparent pipeline. Guys, please, up to this point, do you have any questions, please? Up to this point, do you have any questions? Please, any questions, please? You can unmute, you can talk to me also, please. Please, today what we have discussed, guys, please, today we are understood very clearly. What is an exactly DevOps, we understood very clearly. We have understood. But tomorrow we're discussing about what is cloud, what is multi-cloud, and we are going to be discussing. And tomorrow onwards, we're going to be start our practical sessions also. That is an exactly class for today. Tomorrow, we'll discuss about what is the cloud, multi-cloud. That's it, guys. Please, today we'll continue by tomorrow. Thank you. If any questions, please ask me. Kiran and John. Kiran and John, please. Any questions, please? Okay, Kiran Kumar and Jack will continue with tomorrow. Thank you.